Okay, so welcome to lab, everybody. We're going to do a couple extractions. I'm going to do one where we know what the things are. I'm going to see how that looks. And we're going to draw out an extraction diagram as we go. And then the other one will be an unknown. So we'll have to see what evidence the extraction shows us to figure out what the molecules are. At the end, we'll figure out exactly what they are by using IR and NMR, maybe a melting point too. See if I get to it. I'm not that excited about melting points, but they're good to do. So let me share my screen to show you the first part. And please interrupt me when I'm not on screen or if you're confused about anything. Okay, so this is what I'm thinking. For the first one, I'm gonna take about 50 milligrams of benzocaine. I'll draw that out for you. That's the active ingredient in like Orajel and long-lasting condoms because it's numbing. It makes things numb. And also it's used to cut cocaine because cocaine's numbing. And then I'm going to also use 50 milligrams of benzyl. It's a diketone. I'll show you shortly. And I'm going to try to dissolve that stuff in methylene chloride and do an extraction following this procedure here. And right now, these are just words. It's just an outline for me, but it'll make sense as I go through and I draw out the structures. And I think that is the most important part about an extraction. If you know what the molecules are, draw them out and look at them as you're doing it. Don't, unless you're like very familiar with the molecules and you've got them in your head, you should always draw them out because then you're way less likely to make a mistake if you're like understanding what you're doing. A lot of times people get caught up in an extraction where they're like just following a procedure where they're going down the list. Okay, add methylene chloride, extract with 1 molar NaOH, separate. And then because they're just a robot, they're going through the steps, they always tend to make a mistake because they're not thinking about, oh wait, when I added the sodium hydroxide, that deprotonated the carboxylic acid, put in the aqueous layer, I shouldn't have thrown that out. And that happens all the time. Students will put something in the waste bottle and they're like, oh, my product that I spent 4 lab periods trying to make, I just put in the waste bottle. So we don't want to do that. So let's get started. I'm gonna, okay, benzyl looks like this. The diketone. Vicinal diketone, not vicinal like we were talking about in lecture. They're on adjacent carbons and they have phenols on the ends. Yep, so that's benzyl. So I'm kind of making this experiment up as I go. I'm not using the setup that we had planned for everybody at the beginning. So I was looking for benzyl, and I think it's this one because it's yellow. Can you see on my little screen the jar? I think I'll stop sharing so I can see. Yeah, so I'm pretty sure this is benzyl, but I want to make sure. So what I'm going to do is I'm going to take a quick IR of it. So let's go into the IR room to make sure it's benzyl. I'm gonna get some goggles too. I'll get some goggles since I'm gonna be opening up the agent. Okay, so we'll start off at our IR spectrometer. It's been a little while since you've seen it, but here it is. I'll start with just this Spectrum software here. I'll double click that to get it opened. Let me know if the screen looks okay. How's that monitor look for you guys?
It's all good. There's no flicker or anything.
Okay, good. So administration, I'm going to say I'm an administrator. There's no password for this one. And remember, the first thing we want to do is to take a background scan. So I want to come over and look at my ATR adapter and see that it looks clean, and it does. I was the last one to use it, and I cleaned it. So I'm going to say it's clean, and I'm going to run a background scan to scan air and inside of the instrument. So I'm going to come up here to the instrument panel, instrument scan background, and then I'll just use these default settings, 4 scans, single beam, all the rest of it. I'll just click OK, and it's going to start scanning the background. So what it's doing is it's sending wavelengths of infrared light through our sample and seeing if they're absorbing, not our sample, just through the internal components of the instrument and also air. And it's going to record this background, and that background looks good. That's what it should look like. Can record that and save it so that when I run what I think is benzyl. It'll subtract out the background signals, the air and the internal components. So let's click overwrite. And here I'll look a little bit at these peaks and remind you what they are. So I'm gonna go up first and get this vertical cursor, which is this guy. If I click on that, it clicks it on, see the yellow, the green line here? I can turn it on and then I can turn it off. And I could turn it on again and off again and on again. And John, what should I do?
Leave it on.
Good. Yes, there we go, there we go. Okay, so I can come over here, and if I go onto a signal and I double click, it gives me the number for it. So this is at 3,851.42. I can label a few of these just for practice. Oh yeah, double click, that's good. I got something here. Ooh, a little less than 3,000, 2,920. What do you think that is, Daniel? Functional group shows up then.
Just under 3,000. That's the sp3.
Yeah, sp3 carbon to hydrogens. That's right. Does anybody have a guess at what this one is in the middle of the screen? It looks kind of carbonyl. So yeah, that's carbon dioxide, huh? Can you hear me again?
Mm-hmm.
Yeah, cool. All right.
Just
so
when you walk into the lab, you get a little laggy.
Yeah, I bet that the internet, the Wi-Fi is a little weaker here. I'm not in a hot spot. I'm in a cold spot over here. All right. So now I'm going to delete this one. I'm going to hit just delete the background, and I'm going to add some of my, just in case I'm getting laggy, I'm going to add some what I think is benzyl in here and check it out. So hopefully you can stay with me. But that, cover up my zinc selenide crystal. And then I need to crush it all the way down nice and tight. Go scan sample. Accept the default values and wait. So are you guys able to hear me at the moment? Oops. Is this benzyl? I don't think it is. I'm going to take a picture. Here, I'll show you how I clean it off. I'll get them white. Wet it a bit. Pick up that most of it. I think it might be benzyl and something else. DPS. I'll share my screen with you guys too. Are you guys hearing me okay again?
You said the molecule was a benzyl?
I don't think it is. I think it might actually be benzyl mixed with something else. Yeah, so this is what it's supposed to look like. Let's compare it to what I got from the RIR. So they look, I have a feeling this is benzyl plus something else. I think it might be, it looks like a carboxylic acid to me. What was that? I'm gonna go grab that file again. Yeah, I think it might be like a orthotoluic acid and benzyl perhaps. So I'm wondering, should I do it or not? No, I don't want to do this. I'm going to switch up my procedure. I'm sorry, you guys. Or you know what? I'm just going to go grab the benzyl. We have some in the stock room, so I'll be right back. Give me like 2 minutes. Sorry about this. Let me stop the share for a second. So I went into the stock room and just grabbed the bottle. I should have just done that at the beginning. But when I was looking at it, it has that same yellow color. I was like, oh, that's benzyl. We're good to go. And I think the unknown that I had, I think it is benzyl, but it's benzyl mixed with, I'm guessing, orthotoluic acid. But this is just benzyl, so I want to use just benzyl. So let's go over it, and I'll do what I was saying before. I'm going to weigh out. Oh, actually, before I do that, I'm going to tell you how we're going to do. We're going to use a certain type of instrument for this. I'm going to be weighing this benzyl into a container, though. The container I'm going to use is a centrifuge tube. For small scale extraction, centrifuge tubes are nice to use for the extraction. That's what I had in the diagram for for the intro to this. It's kind of a shorter centrifuge tube. So we're going to use this. So since we're going to use a centrifuge tube, I want to make sure it doesn't leak. What I'll do initially is I'll kind of just lightly run my finger across the top and feel for chips or little cracks in it. And I don't. It feels pretty good. And I also want to make sure the cap is good. Inside of the cap, it should have a Teflon disc. See how that, probably hard for you guys to see. See how it's a little discolored, like gray? If you're live, you'd be able to see that that is a Teflon disc in there. Maybe you can just see it now. That's going to help seal it. But still, sometimes you cap these and you think everything's good. It feels like a good seal. But when you have an organic and an aqueous layer, 2 layers, and you shake it, it'll leak. So I'm going to try to test to see that it doesn't leak. But yeah, I'm going to test to see if it doesn't leak first. So I'm going to add a little water to this. Grab a water bottle. I just went ahead and added a little tap water. So I'm going to cap this and then just start slow, give it a little tilt. Yeah, it looks pretty good. It's not leaking at all, so that's good. This is ready to go. I like it. I'll use this one. Dump the tap water in the sink.
The tap water won't contaminate it?
No, well, if I was really worried about it, I could use DI water. But for most of what we're doing, tap water's fine, especially in Sierra College area. Our water doesn't have that high salt content like you get like at Davis. When I was at Davis, the salt water was, the tap water there is harder, has more ions. Or we will see when I'm done with my extraction. If it looks like our IRs look good, we figure out we did do the separation, then we're going to say tap water is good. So I'm going to label this MFS, put the date, 3/16, 2021, and then we're going to add to this benzyl and benzocaine, benzocaine and methylene chloride. Okay. So we got this ready. So now I'm going to go measure out what I'm going to use for this experiment. I'm going to be using about 50 milligrams of both benzyl and the benzocaine. It's over by the scale. And I'll weigh it out first on just a piece of scratch paper, and then I'll add it to my centrifuge tube that way. I could have just added it directly to the centrifuge tube when the centrifuge tube was dry, but I don't want to do that now that it's wet. Here we are in lab. Got our scales over here. Maybe if I go like that, that's pretty good. All right, so I'm shooting for about 50 milligrams. Let me turn on the scale first. And I'll bring the camera closer so you can see what I'm getting there. This actually, if I put this piece of paper on here right now, it's not going to be good. I'll show you why. So the scale is right here. That's what we need to put things on to get the mass of. This is not the scale. So if my paper's resting on that outer rim, that'd be bad. So maybe I'll just cheat it. I'll go like this. There we go. So I can measure it like that. And then I'll go ahead and tear that. Looking pretty good. Now I'm going to set you down and get some of the solid out. So should I add my benzyl just straight onto the piece of paper while it's in here? Like maybe through the top, just do a quick like 3-pointer?
No.
Should I go through the top? No. What about just like from the side, like kind of just toss some up like that and hope it hits? No. I want to always take whatever I'm putting my material on out of the scale and measure it out of the scale. This way, if I spill a little bit, it's on the counter, super easy to clean up. It's not in the scale. So I got a little bit to start here. Let's see what that looks like. Ooh, I went over a little bit. So 50 milligrams would be 0.05, and I'm at about 0.0799. So I'll take a little bit back. So should I put it back in the reagent bottle? I think it's okay because this piece of paper is clean, my spatula is clean. I don't like to waste chemicals. Boom, I'm gonna put a little bit back, put it in the scale. Let's see what we get. Oh, it looks pretty good. I got 0.0513, 514. I'll go with that. I'm going to type that into our Jamboard. Let's see. So this was the benzyl. We got 51 point. Oh, it's going down a little bit. Let's go 51.4 milligrams. Okay. Now this amount of benzyl, I'm going to put that in my centrifuge tube. And since it's on a nice crease here, I should be able to do it. Get a good transfer. Yeah, that worked out pretty good. So I've got a little bit of benzyl in there. Okay, next up is the ethyl 4-aminobenzoate, otherwise known as benzocaine. So I'm going to do this not on the exact same piece of paper because I have maybe some dust of benzyl on this, and if I add too much, I don't want to add that back into my reagent bottle. So what I'll do is I'll just grab another piece of scratch paper. Be right back. You can also use whey paper for this, but scratch paper is fine. A little smaller. Okay, let's put this on my scale and zero it first. Looking good. And now I'll get some ethyl 4-aminobenzoate, aka benzocaine from Oragel and things like that. I'm going to take my paper out of the scale to add it, just in case I spill a little bit. Put it back in the scale, see what we get. Oh, we're a little short, about 17 milligrams. Sorry, I wasn't angling very good there, was I? Taking my paper back out of the scale. This benzocaine is not as dense as the benzyl. I'm having to add what looks like a lot more solid. Looks pretty good. 0.0451. Let's go with it. Actually, you know what? I'm gonna add a pinch more. Never mind. Okay, now I'm at 0.0591, 585. Okay, I'm gonna go with this. That scale's kind of all over the place right now. Not too bad, but close enough. So I'll look back and tell you what it says right now. It says 59.0 milligrams. All right, and then I need to add that to the centrifuge tube. And here's what it looks like. Got it. Oh, yep, got it. There we go. All right. So I've got benzocaine and benzyl in here. And now I've made a mixture of the two. I want to separate them. How am I going to separate them? With extraction lab techniques. And you guys are going to tell me how to do it. First, I'll add some methylene chloride to this. This is my benzocaine. Then I'll start drawing it out, and we're going to look at the structures, and you're going to say, do this, do that. So I've got some methylene chloride here. Remember, methylene chlorides are dense organic solvent, non-flammable, which is weird. And it's going to usually be on the bottom layer. I've never seen it go on a top layer because of the density. I'll grab a graduated cylinder. the volumes that we use in these type of experiments, they aren't all that important. They're approximate is what I mean. They're important, but they're not, you don't have to be super precise with them because we're doing everything generally in excess. So I'm gonna first drop some methylene chloride and see how it's dripping. Am I on video? Yeah. But if I push that out and drop some more, it's gonna evaporatively cool the inside of the pipette. And so now it's not gonna be so drippy on me. Whoa, there's some chunks in this guy. I think there was maybe a past your pipette bulb in this for a little bit. Looks like it's got bits of rubber. Not looking pretty. Let me grab another bottle if we got one. Actually, I'm gonna just prepare some fresh methylene chloride for us. Just a second. I'm gonna put this in a waste container. And so this right now, what we're doing right here, called research. Completely common. Something always goes wrong and you just gotta be a good sport about it. Find your way around it. So I poured out that contaminated methylene chloride and I'm gonna pour in some more. And before I do it, I'm gonna do something else too. Teach you some more good lab technique. I'm going to add, when I pour this in, there's little grooves. No, it kind of seals the short stem funnel kind of seals on here and it can cause problems with air not being able to come out as the methylene chloride goes in. So I'm gonna stick a pipette right here so that now there's an opening for air to escape as I pour liquid in. And at first, I'm only pouring a small amount. Set that down. And I'm gonna swirl this around to get out any more little rubber bits that might be in there. And I'm gonna put this in the waste container too. I'm gonna do just one more of those. Okay. So I was just pouring that into the orange waste containers you saw in previous experiments. Okay, so now let's fill this up some. If I didn't have that pipette in the side to let air come back out of here, it would the short stem funnel would fill up much quicker. Okay, that's plenty for now. Okay, so now I've got some methylene chloride in here and it's dripping out of this new pipette. I got a new pipette too, so I'm gonna draw up some liquid, push it out, draw it up, push it out, do that a couple times so it doesn't drip so much. Okay, back in action. So now I can get about, I'm gonna start off with about 4 milliliters of the methylene chloride. So about 4 or 5 of these pipettes full. I could use a SEP funnel to fill this, but I think with just 4 milliliters, this pipe, I mean, I could use this, yeah, the short stem funnel, but I'm gonna use the pipette here, almost done. And it's only approximate. Okay, I'm hoping that when I add this methylene chloride to my centrifuge tube, it'll dissolve both solids completely. I'm gonna use the separatory funnel again, and I'm gonna hold it in a way, I'm not gonna set it like that, because then it can have like a problem with gas not being able to escape. I'm just gonna hold my fingers like this so it can more easily let gas out. All right, so I got about 4 milliliters. And is it looking like it's dissolving? It's looking pretty good to me. There's some stuck on the top, but everything down below is dissolved. I think this is working good. So I'll cap it and I'm gonna invert it, like kind of shake it up so I can get all that. But I'm gonna be careful because I checked this for leaks with water, but sometimes the organic solvents will leak even though the water wouldn't leak because they're a little thinner, but it's looking like it's pretty good. Yeah, I like it. So yep, I think everything's dissolved. What do you guys think? Pretty good, right?
It looks like it, but
yep,
your resolution
looks good on my end.
is probably better than ours. So
yeah, you'll have to trust me on this one. Okay, so now I'm going to try to show you the extraction diagram. it's got an ester on one end of a benzene ring, an ethyl ester. And then the other end, it has an amine, but really we call it an amine, but it's an aniline because when you have the nitrogen attached directly to the ring, it's not as basic. It actually resonates into the ring, changes it a little bit. So that's benzocaine. And we also have benzyl. And the benzyl, remember, is the diketone with 2 benzene rings. Okay, there's our benzyl and methylene chloride. And so when you look at these, do they look like they should be soluble as I said they were? Do they look, which one looks more nonpolar to you?
Benzyl.
Yeah, benzyl is very nonpolar, more nonpolar, I'd say, because it's got just the 2 ketones. This one's still got some polarity on the amine and on the ester, but it turns out they're both overall nonpolar, so they're not very water soluble. They're both dissolved in the methylene chloride organic layer well. What can I do now extraction-wise to separate the 2? What can I add? I want to add some sort of aqueous solution that's going to help separate them.
HCl.
Yes,
Sure.
why would I add HCl?
Because it will protonate the amine on the end.
Yes, that's one of our big 4 reactions. You got it, yeah. So here I'm going to box this out. Let's say this is my first step, right? And I'm going to say this side's my aqueous, this side's my organic. And I'm going to add about 4 milliliters of 1.0 molar HCl aqueous. So what is that 1 molar HCl mostly?
Water.
Yeah, it's almost all water. That's what's going to create our aqueous solvent. And then what else does it have besides water?
Hydronium.
And what else?
Chloride.
Chlorine.
Yeah, chlorine.
Chloride. No, chloride. Chloride.
Oh, is it chloride?
All right. So, yep. So we're going to have mostly water over here, chloride and hydronium. And you said the benzocaine will react. What will it look like over here?
What is it called? Ammonia? Or
Yeah, it's going to be
Yeah.
a protonated amine, NH3 plus. So it's going to have that positive charge, and that's going to make it water soluble. Okay, so do you think the benzyl will react with the hydronium?
no?
It won't, huh? So is it going to stay in the organic layer, do you think?
Yeah.
That's what I think too, yep. So the benzyl will come over here into the organic layer with the methylene chloride. And this one's kind of nice because we know benzyl is yellow, huh? So we can watch color-wise when we do this. So we have methylene chloride, benzyl. We might have some unreacted benzocaine too. We don't know yet. So I'll just leave space for that. But I know for sure, I'm not know for sure, but I'm pretty confident. Benzyl will be here, methylene chloride will be there. What else should I put in this box?
I believe last time we said trace H2O.
Yep, there'll always be a little bit of water in there. Okay, and we could have some unreacted benzocaine there. We'll see. So let's do it. So I've got my 1 molar HCl here, which is mostly water, even though the label just really focuses on the HCl, which there's almost none of. And I'm going to do about the same volume, about 4 milliliters. 1, 2, 3, 4. I get about 4 milliliters. Oh, I went over. Oops. Here, I'll get something clean to put it in.
Can I ask a question?
Definitely.
So will the benzocaine completely be in the aqueous solution, or will it still remain in the organic layer a little bit?
I'm gonna predict, because from experience, that there'll still be some benzocaine in the organic layer. I'm gonna check for it though by precipitating it. You'll see shortly, it'll make sense. Okay, so I'm gonna add the 1 molar HCl. I'm holding this so that I'm holding it a little above. I'll hold it this way, right-handed. So I'm gonna let some air out as this goes in. All right, I got that in there. It definitely looks like 2 layers for sure, huh? And right now, can you see the difference in clear and clear yellow,
Yellowish,
clear,
yep.
clear? Yeah. So right now, there's only a reaction occurring between the 2 phases, the organic and the aqueous. It's only interacting right at the surface, you know. There's actually a little organic sitting on top of the water, the water's surface tension. But so there's not really great reaction conditions now. What can I do to help this reaction take place, help the amine get protonated?
Shake it up.
Yep. And when you shake it up, you got to be careful at first, because usually it's an exothermic reaction. It can build up pressure. So if I just cap this tight and shook it a bunch, and then when I first open it, it might kind of vent on me hard. So I want to cap it good. And my first little shake, I just kind of do a tilt. And then I like to tap the cap to make sure nothing's stuck up there. And then I'll vent it. Let's hear if we can hear anything. I don't know if you heard it, but I heard just a little bit of a vent. So I'll do that again. And I didn't even hear a vent that time. So I think it's good now. It's kind of gotten through the beginning part. So I'll give it more of a shake, vent. Yeah, I'm not getting any venting. So I can really give it a good shake now. And you'll see after I shake it, it'll slowly start to separate out. Do you see that? Pretty cool, huh? The more dense methylene chloride is sinking to the bottom. I can do this some more. Nice separation. One thing that's nice about doing this small scale extractions in centrifuge tubes is if you have trouble with this separation, sometimes you get what's called an emulsion, where you'll get like 1 layer on the bottom, then like kind of a cloudy mix, and then a layer on top. What you can do is you can put this in our centrifuge and it spins it, and it makes the more dense layer sink to the bottom more. Okay, but this one's separating out well. So we're looking good. I've got the 2 layers. They're pretty well separated. Sometimes I kind of tap at it. And what do you think I want to do? Do I want to remove the lower layer by putting a pipette through the top layer and sucking it out? Or do I want to try to remove the top layer?
The lower?
Yeah, why the lower layer?
Is it because it's the organic layer, it's nonpolar, meaning that there are no like dips or anything like the top layer? It's easier to take out.
It's more about the shape of the flask. You'll see it gets narrower at the bottom. It's easier to separate that way. So I just got to grab a pipette bulb and I'll demonstrate. So, and also I'm going to put this lower layer into a test tube. So I'm going to label it. I'm going to give my initials, the date. I'm going to say first lower layer. And I'm going to say it's methylene chloride. I'm like 99.99% sure it's methylene chloride, but I could make a mistake. So I always like to check it, and I'll show you how I check it. But first, let's get it. Oh, I'm going to do something else too. Here's a nice pro tip. I don't know if you can see it on your end, but there's a little bit of organic layer on the upper part of the water there. So if I try to suck along the top of the upper aqueous layer, and then I deposit it at the interphase, that organic will then kind of associate with the lower organic layer. Okay, here we go. So I'm going to, I'm going to stick my pipette through the aqueous layer. And what I like to do is kind of push the bulb and give it a little pressure so it won't grab any of the aqueous layer. And then I go down to the bottom, maybe That's a nice draw of some of the lower aqueous layer. And then when I'm coming out of the aqueous layer, I kind of go quickly so I can not pick up any. When I'm coming out of the organic layer, I go kind of quickly to try not to get into the aqueous. So let me try to do that again. It's looking pretty good. And see how the organic layer now is getting narrow on the bottom? It's going to be easier to separate these two because of the narrowness of the centrifuge tube. Now this part, I got to be careful. I just got to do my best. It's not going to be a perfect thing. That's
You can't really see the bottom end of the centrifuge.
Sorry. Oh, I blew it. I'll do it again in the next extraction. So I did remove the lower organic layer completely, and it was getting narrow at the bottom. Sorry about that, but I'll do it again. Okay, so this should be my upper organic layer, right? I'm going to put this aqueous layer in a side test tube here. This will be my first aqueous layer, and this is going to be, I believe this should be the ammonium, huh? It's acidic. Oh, did it work out nice in terms of color? I'll show you the extraction diagram first. So this is my aqueous layer. And that's what I predict is in there, right? And this is my organic layer. Is there something that's suggesting it's going well to you visually?
Yeah,
What's that?
the color.
Yeah, benzyl's yellow. Looks like it's in the yellow organic layer. And this is white. When it dissolves, it's just clear, the benz. But I want to do something that I always want you to do, and I need a water bottle to do it. I'm going to put DI water in the water bottle, just because I was lazy before, but I don't even think it matters much. But there we go. So this DI water, I'll use this to test to make sure this is the aqueous layer. If this is the aqueous layer, when I add the DI water, should it create 2 layers or dissolve?
Dissolve.
Dissolve.
Yeah. I added a squirt, it dissolved. Looks good. If I put the water in this organic layer, it'll form 2 layers, huh? I can actually do it because it won't matter for the next part of the experiment. I'll show you. So let me put a squirt. I didn't put quite enough. Let me do a little more. Do you see how I've got a separate layer on top?
Yes.
Yeah. So this is definitely my organic. This is definitely my aqueous. What you should do whenever you do an extraction, and every time you separate an organic and an aqueous, you're usually pretty confident. Oh yeah, this is the aqueous. Just shoot a little water in the aqueous to make sure. And I normally wouldn't shoot it in the organic because I just want the organic to be organic. But I know I'm going to extract this with another 1 molar HCl, so it's okay. So I've got my aqueous now, and I know it's aqueous. I think the ammonium's in there. What can I do to prove that it's in there?
Should we extract it one more time, or should we use?
Oh, I want to, before I extract it, I want to check this guy. When you say extract it, I think you mean the organic layer, but
yeah.
I'm going to pause there. I want to prove that like the amine that was in the original flask came over here as an ammonium. I want to prove that. How can I prove it?
Could you add NaOH?
Yes, yes. I'm going to make this basic. I'm going to change this aqueous layer from acidic to basic. So I'm going to add, what kind of NaOH should I add? Should I go 1 molar? 6 molar? What do you think?
1 molar. I don't actually know.
I'm gonna go 6 molar NaOH because I don't want to have to add a lot of water. I'm not even gonna do 4 milliliters. It's gonna be more like, it's gonna be less than 1 milliliter because it's 6 molar. I have to quench the 4 milliliters of 1 molar HCl. So I'll need, since it's 6 molar, I'll just need like about, I don't know, 0.7 milliliters or so. You can.
What
do
was
the
that
math
from
if
the
you want.
first lab we did this semester? We talked about that a little bit.
Yep. I was saying that whenever we start an extraction, start with 1 molars because it's not too concentrated. It won't like cause any problems. Like 6 molar NaOH might actually start to hydrolyze the ester here. If you can see that ester. 6 molar NaOH could maybe start to slowly hydrolyze that, react with it. But 1 molar won't, and 1 molar HCl won't. But now the 6 molar, it sounds like, oh, it's going to be harsh, but it won't because I'm going to be adding it slowly and it's going to constantly get quenched by the hydronium. So we're going to go 6 molar. I've got it here. And with the 6 molar, that's getting a little bit concentrated. It's not too bad. You could put on gloves at this point, but I think I feel safe and calm with it. If I do get some on my hands, I just wash my hands right away. And as I'm washing my hands, they feel slippery because it turns the oils in your hands to soap. So it feels like you have to keep rinsing your hands because your hands, the oils are turning into soap, turning yourself into soap. Okay, so what I want to do then is I want to slowly add the 6 molar NaOH to my acidic, what I think is the ammonium. And what is that 6 molar NaOH made up of both mostly? Mostly water still. It's like 50 molar water and 6 molar sodium, 6 molar hydroxide, right? So we're still adding mostly water. Is there going to be a reaction? Yes, there will be a reaction because the ammonium reacts with hydroxide, gets deprotonated. Before I do it though, I'm going to do something. This solution should be acidic, correct? This one?
Yeah.
Hydronium. Let's double check. Let's make sure. How do I check the pH of a solution?
Use a testing strip.
Yes. Should I just tear off a big long strip and dip it in there?
No.
No. I'll just tear off a tiny little bit at the end. Stick that on a piece of a paper towel. And then I will take a spatula. Oh no, here on that side, it's reversed my view. All right, and then I'm gonna take my spatula and I'm gonna put it, I don't wanna just tip the top of this, barely touch the solution. I wanna really put it in there, swirl it around, make sure it's completely saturated with whatever solution this is. Okay, and then I'll touch it to the pH paper, and if it's acidic, what color should it be?
Reddish.
Reddish.
Yep, it was evaporating. I think a little faster. There we go. Oh. There we go. It's acidic. Pink, right? Good. So I'll put that on my notes here. pH paper pink. That's about a pH of about 2. Okay. All right, now I'm gonna do the fun part. I'm gonna add the 6 molar NaOH and see what happens. I'll get this closer to the screen. Okay, I think you got a good view now. Oh, also this 6 molar NaOH bottle, it's plastic, it's not glass, and the pipette is plastic too. Does anybody remember why I'm using plastic for the hydroxide?
I believe you can eat away at the glass, or
yeah, hydroxide will slowly eat glass away, so you don't want to store it like 6 molar. You can store 1 molar hydroxide in glass, but not 6 molar. Okay, here we go. I'll put my first drop in here and watch. This is pretty cool. Oh, it's working its way down the side. I'll do another one. Do you see that? I'm not sure if you're getting a good enough view of it. Okay, here it is. So I can't believe I'm doing this above my computer keyboard. So I'm gonna do another drop. See what happened there?
Mm-hmm.
What's going on? Anybody have a guess?
Well, there's a precipitate forming, but then it's reacting with the excess acid in the solution that's then contacting it and it's going away.
That's it. So as the concentrated hydroxide or 6 molar hydroxide is coming through, it creates a little local environment of like a basic solution. And all of the ammonium gets deprotonated there, and it becomes now no charged organic and precipitates. But then there's like excess hydronium that rushes in and reprotonates it again, makes it soluble again. So do you think I've gone to the point where I've taken the solution that was acidic, it was pink. Do you think it's now basic yet? It's not.
Not just yet.
Not just yet. We got to keep going. Ooh, the precipitate's not going away now, huh? Well, maybe it is. Maybe it is. I'm getting close. I'm basically doing a titration. I'm making this acidic solution, bringing it towards the midpoint, and then past the midpoint to the endpoint. Let's see if we get a go past the equivalence point, and oh, look at that! It's almost all white solid now, huh? What's that white stuff? That white stuff is benzocaine. We deprotonated the ammonium.
Oh.
Now this not very water soluble, precipitates out. There's no organic layer for this to dissolve in. We're over here on the aqueous side. The organic layer is off, over here. Methylene chloride's over here. Okay, so do you think I've added enough? Do you think it's basic?
I think so.
Go ahead and just. It might be, but you know what? You should always, always, always check the pH, because we may not quite be basic. We might not be all the way basic, and if we aren't, then we're not going to get a good yield of precipitate. So I'm going to check it. I'm going to put another piece of a little strip of pH paper on a piece of paper towel. And I'm going to take my spatula. And my spatula I used before on the acidic solution. So it's got a little bit of acid on it, the spatula. So if I use it, if I just barely tap in here, I might get a bad reading. Can you guys see this? Yeah, you can see it. So if I just tap like that, I'm not going to get good reading. I want to like put it in there and swirl it around and really get it like, coated with what I'm testing. Bring it over and check it. Oh, I think it's basic. Looks good. Well, it's kind of purple. Let's see. Yeah, no, that's pretty basic. I don't know, man. I got a gut instinct. I want to add a little more. Let me try. Yeah, no, I guess that's good. Okay, so this will be our first precipitate. Oh, I'll check the pH again. See if that made a different color. Yeah, that's a little darker. Okay, yeah, I think that was probably a good choice. All right, so that's our first precipitated aqueous layer. This one, if you remember, I was talking about the way to get this kind of a product out of the aqueous layer is there's two ways. You could filter it through filter paper, or you can extract it with the organic solvent, like fresh methylene chloride. When you look at this, it's pretty fine particles, huh? Do you think I would want to filter this or extract with methylene chloride?
Extract.
Yeah, I think if I try to filter this through filter paper, it's going to be such a fine particle. Some of it will get around the filter paper or just like caught in the filter paper. So I'm going to probably be extracting that, not filtering it. Okay, so now let me fill in my extraction diagram, see where we're at. So it looks like at this point, I did get a precipitate, and the pH was like purple, huh? Maybe pH of like 12 pH paper. Okay, so I believe I have the amine again, the NH2, not the ammonium. And because it no longer has charge and it's a pretty organic molecule, it's not going to want to be soluble in water. It's going to form that precipitate. And then I have, what is mostly in this, at this point, what molecule is most present? By far most present?
Water.
Water. Okay, and what about some ions?
Sodium, chloride.
Sodium, chloride, good. What else? Is there much hydronium left? There's almost no hydronium left. Hydroxide is what I'll put. I think of this as like, I'm just drawing my major species. So the hydronium concentration super low when you're at a pH of 12 or around there. Okay, so that's my first precipitate. Now, I may have more of this benzoin in the organic layer, huh? How can I check for it?
Extraction again.
Yeah, what should I add to it?
Hydrochloric acid again.
Yeah, do I want 1 molar or 4 molar? 1 molar or 6 molar? What do you think?
I think still 1.
Yeah, you start with 1. 1 molar HCl aqueous, which is mostly water. And then I'll put my organic layer on the right again and my aqueous on this side. And let's see what we get. My original centrifuge tube's empty, and I pulled out my organic layer to the side to test it with water, but I could put this back in. And that little bit of water in there, that's okay. It'll just dilute the 1 molar HCl that we add. Maybe it'll make it like, 0.85 molar or something, but just fine, that's plenty. Or maybe I'll decide to add a tad more than 4 milliliters. All right, I got that back in there. And then I'm adding the 1 molar HCl. This had a little bit of 1 molar sodium hydroxide from, no, did it have sodium hydroxide? No, just 1 molar HCl is all this has had. So this is good to use again. Oh no, it had methylene chloride in it last, all good. Okay, looking good. A little more than 4 milliliters, close enough. I'll leave a gap so the air can escape as I add it. And again, it's not going to react well currently because it's only reacting at the surface. So if I cap it, I don't want to give a vigorous shake right away. I want to just give a short, I'm going to actually give it 2 of these so maybe you guys can hear the vent. Let's see if you can hear it. It was too light. I held it next to my AirPods, but now I can give it a little more of a shake. Vent, more of a shake. Vent. Keep venting. Okay, now I feel pretty confident. It's not giving me a lot of problems with the venting. If you're doing an extraction where you have something, a reaction that takes place that creates a gas, then you have to worry about venting. Like if you're using a sodium bicarbonate to quench an acid, it creates carbon dioxide gas, then it can really vent. So you got to be careful with those. And it's separating out again, right? Kind of cool looking, huh? You can see there's droplets on the top layer that are, I can kind of tap at it to make them fall. There we go, not bad. Good to good. And now, am I taking off the lower layer or the bottom layer?
Bottom layer.
Bottom.
Yep. I'll put it back in the same test tube. This is the bottom layer. Yeah. And this time I'll do a better job of showing you how it looks. So drawing off the bottom layer. See how it's getting narrow at the bottom? Okay, I think I did a decent job of separating those two. And then my aqueous layer, I'm going to put it in another test tube. Well, you know what? I'm just going to go ahead and make it acidic here. Or not acidic, basic. So it should be acidic. Let's just check. It currently should definitely be acidic. So if you guys see it. There it is, yeah. Okay, I'm getting a good sample of it. Put it on. Yeah, it's very acidic, looking good. Now I will make it basic again with the 6 molar NaOH. See how it looks. Yeah, it's starting to get cloudy, see it? Nice and cloudy again. Oh, I left a little organic in there. That was not the best. Experimental error. Oh, well. Let's check that pH as well. We've got to make sure we made it basic. Otherwise, we're going to get a bad yield of our precipitate. So I'll put my spatula in there, swirl it around. Check the pH paper. Yeah, that's basic. Looking good. Okay, so we did have excess of amine in the organic layer after the first extraction, huh? So let me show you what I mean. So we did definitely had some amine here, huh?
Mhm.
Can you guys see what I'm drawing okay?
Yes.
Yep.
And then what do we get in the aqueous layer here? Mostly
Benzocane. Or H2O, sorry.
mostly H2O, good. And then did I get, was it the amine I got or something different?
Oh yeah, you got the ammonia.
Yeah. The ammonium again. And then what are the ions in this guy?
Chloride.
Chloride and what else?
Hydronium and
Good.
sodium.
It's acidic. No sodium yet. So at this point, this was our colorless clear solution that then I added 6 molar NaOH to. And when I add that, it's mostly what?
Water.
Water. And does this react with the ammonium?
Yes.
Yeah. And that's our precipitate. This is our second precipitate. Okay, and I also have some ions. What else is in here?
Hydroxide.
Sodium, hydroxide, and something else.
Chlorine.
Chloride.
Chloride.
Not chlorine, chloride, yeah. Okay, that was good. What about my organic layer after the second? You can call it, a lot of times chemists will call this like, oh, I did an acidic wash of the organic layer. You're washing the amine away from the organic layer. So after the second wash, what's this box mostly? What molecule is present the most?
Benzyl.
No, what the solvent? What's the solvent?
CH2Cl2.
Got it.
Ethylene
And then,
chloride.
but then yes, we have benzyl because that shouldn't have reacted. We see the yellow color of it as well. And what else was in there?
Trace of water.
Trace of water. And I bet there's still some amine in here, but I'm not going to do a third one. I think 2 is enough. I'm just going to say probably trace amine. I know this from experience. Because the benzocaine you can do like 6 of these acid washes, and you keep getting this milky precipitate. But I believe we've gotten like, you know, almost all of it out already. And just for the time, I don't want to keep taking so long with you guys on this one. So we need to deal with the organic layer and the aqueous layer. Which one do you want to do first?
The organic.
Okay, so let's say I want to, what should I try to get rid of first? I'm not going to even get rid of the benzocaine, that little bit of trace. I'm going to leave that in there as an impurity, and I'll still be able to figure out that I have this, I think, on IR. We'll see how much of benzocaine I see in there. So I'm going to use a new centrifuge tube for this part. So this is my organic layer after 2 1 molar HCl washes. What do I do next?
Do we do the brine wash? Or?
Yeah, it's up to us actually. Methylene chloride doesn't hold a lot of water in it, but maybe I wasn't the best at separating my layers. I see little spots of water in there, huh? Yeah, let's go ahead and do the brine wash. Brine pre-dry, sorry, the brine pre-dry. So I'll get some brine. It's over on the shelf over here. So here's our brine. It's saturated sodium chloride. You can't see it really, but I can see there's some undissolved solid sodium chloride table salt on the bottom of this. So this is saturated. Okay, so I have to get my methylene chloride into my new centrifuge tube, but before I do it, I should test it. You know how I'm going to test it this time? I'm going to test it with methylene chloride because I don't want the water in there. Well, you know what? It doesn't matter. I'm going to use brine anyways. Yeah, it's fine. So let me add a little water to test this test tube. This centrifuge, so I felt the top, it feels good. Like it's not cracked or anything. And then this cap, the little Teflon disc in there looks good. Tighten it up. Yeah, this feels good. I don't think it's gonna leak. Nice, put that down the sink, that DI water. All right, so let's add this organic layer to my new glass. Got it. If I want, let's say, oh, I want to rinse this out to get the last of that organic out. I could do that. Just pipette in some methylene chloride. Give it a couple squirts. There we go. Okay, so I've got my organic layer in here, and I'm going to pre-dry it. The way I'll do that is I'll first add some brine. I will add some brine. So how much brine? I do about the same volume, about 4 milliliters. I'm just going to pour this straight through instead of pipetting it. Brine's aqueous, and it's real viscous, so it's easy to pour. Poured more than 4, but that's okay. Now I'll add that to my centrifuge tube. I might add less than the full 6. Let's see how it looks. Ah, this looks good. That's fine. I just wanted to make sure my centrifuge tube didn't get full. Got that ready to go. So the brine is on top, organics on the bottom. It might be hard for you guys to see, but let's see. Try to look at that organic layer and remember how clear it is. Is it looking real clear or just kind of clear? And sometimes when you do the brine wash, it clears up. It kind of gives you evidence that it worked. Okay, so before I start really shaking this, I want to just do a loose, like a slow tilt, and then bend. No pressure. Slow tilt, bend. Yeah, we're looking good. Okay, so now I can really shake it up. Okay, let's watch it separate out. See if it's going to do well. Usually the brine will separate better than other aqueous solutions because it's like it's more organic. It's more polar than just water. All those sodium ions and chloride ions. This one's going a little bit slow actually though, but it will separate.
Do you vent because gas forms inside and the lid can pop off?
Not that the lid can, well, the lid could pop off, but I haven't really had that happen. It's more like if I don't vent and I shake the whole time, the first time I vent, it can really release a lot of gas and maybe spray on you a little bit.
Okay.
Now, to me, it looks like the organic layer got a little clear, but I don't know if it looks as good to you on your end. Does it look a little clear? So I did the brine pre-dry. Let me write it down. This is the key to doing these two, is keeping track of everything. So I did about 6 milliliters of brine. So what's in my aqueous brine layer? Mostly.
Water.
H2O.
Yeah, mostly water. And what else?
Sodium.
Sodium.
Mm-hmm.
Chloride.
Yeah, and that's it pretty much. And then the organic layer. What's
Benzocaine
the main molecule? Methylene chloride.
or benzyl.
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 And should there
And,
be water still there?
Very trace water. Just a little bit of water because we removed the bulk of it with the brine. And then there's also going to be the trace benzocaine, which I didn't do. I didn't do a lot of extractions of it, but it's going to be mostly gone. Okay, yeah, it's looking pretty good now. Separated it out well. And to do the final dry, I'll grab some sodium sulfates. I like sodium sulfate because it like clumps up nice. It's easy to decant from. But people tend to use sodium sulfate for this or magnesium sulfate. Magnesium sulfate will actually grab onto more water. It'll leave your organic layer a little more dry, but you usually have to filter it through filter paper and you have to let it sit longer. It's like slower, but more effective. So sodium sulfate's good enough for me. So what I'm gonna do is I'm gonna do this in an Erlenmeyer flask. You can do it in pretty much any container, but I like to do this part in an Erlenmeyer flask, so let's do it. So I'm gonna label it up. MFS, organic layer, benzyl. All right. So I wanna get my, so I'm gonna push through the aqueous layer, enter the organic layer, draw it up, pull it out quickly, put it in my Erlenmeyer. Can you guys see the bottom of the centrifuge tube?
No, we can't. But I had a question. So as you're pushing through the top layer, you're kind of squishing the bulb so nothing gets in. Is that right?
Yeah. That looking better?
Yep.
Yes.
And then at the end, you just kind of go slow. And with experience, you get better at this kind of thing. So I'm gonna go, I may have gotten a little bit of brine in here, but I'm okay with that because I'm gonna add sodium sulfate and that's gonna get the rest of it. That'll get out the water that came in with the brine. And the sodium chloride from the brine will precipitate out at that point. When there's no water around, sodium chloride is not soluble in organic methylene chloride. Okay, so now it's time to add our sodium sulfate. And as I was saying in the intro here, actually I'll rise this up a little bit. I look better with black. So as I'm adding the sodium sulfate, it'll start to clump as it grabs onto the water, and it'll also make the solution look clearer. I don't know if you'll be able to tell on your end, but we'll see. And also, can you see I think I could see a couple little beads of water. This guy's still got a fair amount of water in it. I could redo the brine and separate better, but it's all right. This is gonna be fine. So I'm just gonna take out some sodium sulfate and drop it in, and then swirl it around. And when I do, I can see the brine. I might even be at the point where I've added enough. Not the brine. I can see the sodium sulfate like clumps up. Can you guys see big clumps of it?
Yes.
Yeah.
That means it's hydrated. When I add sodium sulfate and it no longer makes clumps, it stays the little grains. That means I've added enough because there's not enough water to clump it up. So I'm going to do a little bit more. I think I'm already pretty close. Yeah, I could see a few. Well, I'm going to go a tad more, and then I'll call it. This comes with experience. You just kind of get the eye for it too. But normally when you're in lab, the first few extractions you do, everybody comes up, is that enough? Is that enough? And then after a while, they're like, okay, now I got it. They get comfortable with it. So yeah, I see. I really, one of the main things I can see is it got much clearer, the organic layer. It looks nice and clear. And also, you'll see oftentimes little beads of water stuck to the inside of the glass, and now there's no longer any water stuck to the inside of the glass. Okay, so if we wanted to get this super dry, to be really good about it, I would cover this and I would let it sit for like 15 minutes to really give the sodium sulfate time to suck up all the water. But in practice, it's usually plenty dry at this point, in my opinion. So I'm gonna just decant it now. I'm gonna decant it. What should I decant it into? Like an Erlenmeyer or a beaker to evaporate it?
A beaker.
Beaker?
Yeah, why beaker?
More surface area.
Yep, more surface area. Yeah, so I got a nice size beaker here. I think that's gonna work good. So let me write on it. Benzyl 31621 MFS. Okay. Oh, before I decant it, what should I do with this beaker before I decant it? I'm gonna let the methylene chloride evaporate, right? Then I'm gonna have solid benzyl left over. What would be something interesting to know about it?
Its melting point range.
The
Maybe,
mass.
but the mass, yeah. So wouldn't it be nice to know the mass? I started with, I weighed out how much I started with. It was about 50 milligrams. So how can I get the mass of it?
I'm measuring the mass of the beaker. And then once we decant the dry organic layer, we can measure it again to see the mass.
You got it. Let's do it. We'll go over to the scale. This mass. So I'll go ahead and zero it out. Put in the beaker. Looking about 30.845 grams. 30.0845 grams. So for the decanting, I just simply carefully pour the liquid out, and I don't want the solid to come. I want to keep that solid behind. I pour it like that, and we hold it on the edge. And I'm fine with leaving a little bit of the organic layer behind, because I'll show you what I'll do. After I decanted it once, I can take now some fresh methylene chloride that's dry and add it to my sodium sulfate to rinse more of that methylene chloride off of it. And then I can swirl it around, decant again. Maybe do one more rinse. And I can tell the sodium sulfate after the first decant was a little yellow, but now it's not so yellow. Okay, got it. Decant again. All right, so now I'm just gonna let this guy evaporate. If I just hold it here for a while, it'll start evaporating pretty quickly. The boiling point of methylene chloride is 40 degrees Celsius. And as it evaporates, this outer glass will feel it get cold because of the evaporative cooling. And that'll slow down the evaporation. So if I want it to go a little faster, I can nest it in another beaker that has some warm tap water. So I'll go ahead and do that. Let me get some warm tap water in another beaker that's just slightly larger. So I think this beaker here will be a good size. Yeah, it'll just fit in there and it won't fall over. So let me get some hot tap water. It might take a second to warm up. And then while that's in the warm tap water bath, I could hit it with the Conair 1875. You know, our Conair, the highly technical blow dryer here. I could be blow drying it to try to speed things up, but then I have to sit there and hold the blow dryer. And I don't feel like doing that. So instead, I'll just set it in the fume hood and let it evaporate on its own. And while this is evaporating, I'll go back to the aqueous layer in the from the extractions earlier. I'll get the benzocaine out. So let me get some of that warm water I was telling you about. And I'm just going to put a little bit in here. Yeah, like this. That works good. And I will bring this over to the fume hood behind the computer here. Just set it somewhere where there's a good airflow. It'll evaporate a little bit quicker in there. Okay, so back to our extraction diagram. This is key to not getting confused because there's a lot of little steps to this. It's easy to mix stuff up. So I redrew up my organic layer from the last page of my notebook, and I have the benzyl, methylene chloride mostly, very trace water because we did a brine wash, and then just trace benzocaine. I add this anhydrous sodium sulfate, and it creates a hydrate over here, hydrate, and then the organic layer here. So what's in the organic layer on the right now? Mostly methylene chloride. Can you guys hear me?
Yes.
Yes.
Good. And the benzyl. And let's say we got rid of all the water. I'm sure there's a tad of water, but let's say it's so very, very, very trace, we'll ignore it. And there's probably still some trace benzocaine. And then over here, the hydrate, you'll have sodium sulfate. And I think maybe the most common is the hexahydrate. So it can hold on to 6 water molecules per sodium sulfate unit. Okay, so our organic layer, we're just waiting for it to evaporate. This is the, let's say, this guy. Let it evaporate. And then you have a gas over here. What's the gas that's evaporating away?
Methylene chloride.
Yeah, chloride gas. And then over here, you'll have your solid yellow benzyl. And the trace impurity of probably some benzocaine in there still. Okay, so we're waiting on that, and this is done in a 30.0845 gram beaker. So we'll be able to get the mass of it afterwards, and I'll also take an IR to make sure it is benzyl. Mostly benzyl. We'll probably see maybe some traces of the benzocaine. We'll see. Now back to the aqueous layer. So if you remember the aqueous layer, we had 2. Okay, now see, this is where labeling helps. I was looking at this and I'm like, man, there's not a lot of precipitate in there. Oh yeah, that was the organic layer brine wash. Okay, that's the brine wash. This is my benzocaine. Let me double check this too. Benzyl, benzocaine, methylene chloride. No, and here's my first precipitate. Yeah, this is first precipitate. This is the second precipitate. I actually didn't label this that great. This was methylene chloride, but now it's not. Now it's the second precipitate, and you can see it's kind of cloudy, and there's a little bit of organic methylene chloride in the bottom there, and that's probably dissolving some of the precipitate into it, so that's why it doesn't look like a lot. Okay, so back to this layer. I'm wondering if I'm gonna be able to fit them both into here. I think I can. I want to combine them and then extract them. So I'm gonna combine aqueous precipitate, 1 and 2. So in that, I will have benzocaine. Was that someone else getting a phone call? And what else is in here besides benzocaine? Can you ever remember? What?
Water.
All right, good. Okay, so benzocaine, water, yes, mostly water. And what else?
Sodium.
Yes, sodium.
Chloride.
Chloride from when it was acidic, but now it's basic, so hydroxide, right?
Mm-hmm.
So how can I extract this precipitate out of this organic or aqueous layer? What should I add at this point?
The brine that pulls the water out so you can separate the...
No, because this is mostly water. If I add mostly water brine, I just have a lot of water.
Sodium sulfate? What was it?
Nope, that'd be, because this is mostly water. Sodium sulfate, I'd have to add the whole bottle, because there's two. Sodium sulfate's for when there's just trace amounts of water in an organic layer, but this is an aqueous layer.
Would you be able to tilt your computer camera just a little bit down?
Sorry about that, yeah. So,
Actually, no, never mind.
I'm gonna add something to get this precipitated.
Do we add sodium hydroxide again?
No, because I already have hydroxide in here. What is this soluble in? It's currently not soluble in the water. I know it's a fine precipitate, but that like little precipitate you see there is the benzocaine. What is this soluble in when it has no charge?
Oh yeah, HCl.
It's
No,
so 6 more.
hydrogen.
well, it's soluble in aqueous HCl, but what else is it soluble in? We started the first part of the experiment. We took the two solids and we added this solvent to dissolve both of them.
Methylene chloride?
Yeah, I'm gonna add methylene chloride. So maybe I'll add about 4 milliliters of methylene chloride. That'll create an organic layer. And won't this want to go in the methylene chloride organic layer? Because it's neutral.
Oh, so since
And
it's...
then over here, your aqueous layer is mostly water.
Sodium.
What else is in this aqueous layer? Sodium. What else?
Chloride. And do we have hydronium now? No, we still
No,
have.
it'll still be
hydroxide.
basic. Because when we add the methylene chloride, that's not changing the pH or anything. So we're just trying to get the organic molecule that's not soluble in water over into a soluble organic layer. And when we do it, we separate it from the ions.
Oh, okay.
And what else is in this organic layer?
The trace of benzocaine.
This is the benzocaine, so not that.
Oh,
But
I mean,
water.
the trace of water. Sorry.
There might be trace benzyl in there, but not much, because I don't think the benzyls went into the water at any point that much. Okay, so let's do it. I'm gonna combine these two. I think this is a good idea. I think it's gonna fit. Oh, it's kind of heavy. Yeah, it's gonna be fine. It's gonna be fine. Yeah, it's kind of full though, huh? So I've got this combined 2 layers, I know it's not really noticeable, this precipitate, but there is a precipitate in there, and there's some methylene chloride already in there dissolving some of the precipitate for us. Add a few squirts of methylene chloride to this guy, and it's going to dissolve that
We can't see it.
benzocaine. Oh, is it? Can you not see it right now?
No.
How about now? Does that look better?
Yes.
So I've added methylene chloride. It's down on the bottom. And I didn't give myself a lot of headspace. This is a little more full than I like, but that's okay. Well, it'll work. I'll be careful with it. I need to give it a slight tilt back, vent. Okay, looking okay. Feels like it's leaking a little bit. Maybe I grabbed the wrong cap. Okay, slight tilt. Vent, yeah, this one's not venting too much, we're good. Give it a real good shake. Okay, that's pretty good. So what I'm gonna do is I'm gonna let you watch it separate. I'm gonna go glance at our evaporating beaker over here, see what it's looking like. Yeah, it's evaporated a little bit. It's looking pretty good. This guy's separating out well. I got a little methylene chloride and pen on my hands. I'm gonna wash that off. Okay, so I should have, the bottom layer is what, aqueous or organic? Methylene chloride on the bottom, or is that water on the bottom? Should be the methylene chloride. Methylene chloride's our most dense organic solvent we use. So density like 1.33 grams. So that should be on the bottom, and I'm gonna pipette that out. And I'm gonna go into a fresh centrifuge tube, so I just could go a little bit quicker on the next step. Actually, you know what? I'm gonna not even do the brine wash this time. I'm gonna skip a brine wash. I'm gonna go right to a centrifuge, Erlenmeyer flask to do the sodium sulfate dry. So this will be my sodium sulfate, benzocaine, my name, date. Okay. So I'll carefully pipette my lower organic layer into here. Okay, go through. Pipette that into here. And I have, yeah, just a tad more organic in the bottom there. Okay, that looks pretty good. So I've got my methylene chloride layer. Let me write this down too, because I did do this different. I want to keep track of what exactly I'm doing. I went with, I'm going to go straight from this organic layer with the trace water to sodium sulfate. And I should get over here my hydrate, sodium sulfate, say hexahydrate, and my dried methylene chloride and benzocaine over here. So let's actually do it so you can see it. And I don't have to measure this out, the sodium sulfate. Oh, also, can you see like beads of water stuck to the outside of this flask a little bit? See that little bead of water stuck there?
Mm-hmm.
The little droplet like right there. Yeah. So let's see what happens after I add some sodium sulfate. Swirl it around, and what I'm going to be doing is drying the organic layer. Oh yeah, it's nice big clumps this time, huh? It's pretty obvious clumps. And the little beads of water that were stuck to the inside of the glass, I don't see them so much. But I don't see any little fine grains yet, so I'm going to do more. I'm still just seeing clumps. So, oh, I'm probably gonna have to add a little more sodium sulfate because I didn't do the brine pre-dry, huh? Yeah, that's nice. Yeah, it's working out as expected. I'm having to add a little more sodium sulfate. I'm probably gonna add like twice as much sodium sulfate as I had to on the last drying because the last one had a brine pre-dry. Oh, I see a few little grains that are not clumps. I'm gonna do just a little. I do actually see up at the top of my flask little droplets of water stuck there, and I want to wash those down in so they'll get clumped too. So I'm gonna use a little bit of methylene chloride and just rinse that down and in. I think I need another one. Okay. And some more sodium sulfate. I'll go a little heavy-handed, get this done. All right, yeah, I see some grains that are not clumps, some small ones as I move it around. And the solution on my end is much clearer, and I'm not seeing a lot of drops of water on the inside of the glass. So I think I did it good. Now I just need a beaker. Let this evaporate too.
You assume that the drops on the side is water because it sticks to the glass?
Yeah,
Is
water's
that-
polar, glass is polar,
okay.
but the methylene chloride does not. You could tell too, like with the bottle of, well, you can even see now. So I have dry methylene chloride. See how it doesn't really stick to the glass?
Mm-hmm.
You don't see beads of it, like a Coca-Cola commercial where you see like a cold glass of Coca-Cola and a water droplet slowly, seductively sliding down the outside. If you have a droplet of methylene chloride on regular glass, it just falls instantly because it's not attracted to it. All right, so here we go. This is the methylene chloride evaporation, and I've got the benzocaine in here. Huh? And my initials, the date. Okay. And how do I get the dry methylene chloride out of here and leave the sodium sulfate behind? You can't. Pour carefully. If you happen to pour a little too steep and some of the sodium sulfate comes in here, just get a new flask and do it again. And as I did last time, I'm going to rinse this with some fresh methylene chloride. You can see this process of extraction, it's got a lot of repetitive things to it. So the more, oh my goodness, I'm talking too much. I did exactly what I was saying. Oh, you know what I also did? I'm rushing it. Okay. No big deal. I also didn't weigh this beaker.
Oh yeah, I was gonna ask, are we massing this one?
Yeah, I should have. Nothing's lost. It's all good. Give it a couple rinses. And let me get a different, yeah, I'll get a different beaker. You know what? I'm going to try a bigger beaker this time. See how it goes. I'm going to try this big one. So I'm going to just leave the computer here. Trust me on my measurement of mass. Let me get my thing here. So the scale is reading 0 currently. Set that beaker in there. See what it says. It's 101.9009 grams. Okay. I'll bring that back over. I'm assuming my marker ink isn't that heavy, but I am introducing some extra air here, aren't I? All right, here we go. Gonna slowly decant. Maybe don't talk during it. And then methylene chloride. Slowly decant, slow, slow, slow. One more rinse. That should be enough. Okay, so this one's got more surface area because it's a bigger beaker. It'll evaporate quicker, so it should catch up with our other one pretty quick. I'm gonna go walk over and look at it, and I'm gonna bring the, after I bring this over there, I'll bring you over too with the computer, just a second. Okay, look at this. This was our first one. This is the benzyl. It's almost all evaporated. It's just a little bit left. I'm gonna be impatient about it. I'm gonna blow a little nitrogen gas into it. I'll let you guys watch. Okay, here we go. So I'll bring you over to the nitrogen tank. And remember to turn on the nitrogen tank. I like to first make sure this is loose. Have I showed you the nitrogen tank? I think I did, right? Yeah, I'm pretty sure I did. I'll make this loose so I know that when I open the tank at the top, it's not letting anything out. Open the tank at the top, and this gauge, well, it'll go up a little bit. So this first gauge closest to the tank is telling me the pressure of gas in the tank. So currently I have about 8,000 kilopascals or 1,200 PSI of pressure, a lot of pressure of nitrogen gas. If I take this nitrogen gas and I lay it on its side and I sledgehammer off the top, it could shoot like a torpedo through a brick wall. If you look up Mythbusters, they have a video where they shoot a tank like this through a brick wall. So you want to have it strapped down. It's strapped right here. And you want to be careful with it. So I've got this end here with an opening. When I screw this in, I'm going to allow the gas to come out of this. And as the more I screw it in, the more the pressure is. So I'll show you. Can you hear it?
Yes.
And if I go, this will tell me how much pressure I'm actually letting out. It's too low to read right now, but see how as I go up, see how that number went up? You could read it. If I go down, it goes down. So I can control my pressure with this. And now I'm going to use this stream of nitrogen, and I'm going to carefully blow it over the top of my methylene chloride and benzyl to speed up the evaporation. This is like a rich man's way to evaporate things because nitrogen gas isn't free, not the big tanks like this. But since I want to get to the point where we can weigh it and get an IR in this video, I want to just finish it off. Okay, it's looking pretty good. You want to be careful when you do this too that you don't splash it out. It feels very cold on the bottom because of all the evaporative cooling. And another thing I can do is scrape around the solid that's in the bottom of here with a spatula to kind of give it more surface area of the particles to evaporate the solvent. So I'm going to pause on that one. That one's looking pretty good. And then I'm going to see if this might be. This one's good. Oh, that's the water. Here's the water would take forever. This is the benzocaine. And as I'm doing this, it's getting cold. Let's see. It's getting very cold. My pinky is like, feels like I'm touching an ice cube almost because of all the evaporative cooling. And if I put this in a bigger beaker of warm tap water, it'll speed it up. I'm actually going to do that. And so this, I'll turn counterclockwise to stop the flow of nitrogen. So I stop the flow of nitrogen. And then I'll close the top. Always close the top to make sure it's closed off. There's still a reading as if it's connected to the tank. It's just because this regulator is good. If I actually turn this back on, I'll release the little bit of gas trapped in the regulator, and this will drop. You'll see, watch. So you can see, it's even though this is saying gas can come out, it's stopped already. It's stopped right here at the top. But I want to have this loose just in case the next person comes up and they, a common mistake a student might make is they'll twist this all the way in, and then they're like, why isn't it coming out? Oh, I forgot to do this. And when they open this, it's on full blast. It would shoot off the little plastic pipette. But I have washers here to prevent you from going too far. Okay, let's go back to this guy. It's looking pretty good. Pretty good, pretty thanks for hanging with me, you guys. I know I've gone a little over. If you got to go, don't feel like you have to stay, but I'll just skip. Maybe I'll do like a IR of this one, and then I'll get the other one without you, unless you want to hang. So I've got this solid in here, and it's kind of like coating the bottom funny. So I'm going to scrape it around a little bit. I think that's going to help it vent a little more of the organic solvent. Okay. Now I'm going to go weigh it. Let's get the weight of it and record it. So see how much we recovered. So I'll just come over and do it without bringing the computer at this point. So put that on the scale. And I got a reading of 30.1310. Let me get a pen. Okay, I got 30.1312 grams actually when I went back. Let's see how much that weighs out to be. So this is our benzocaine. It was in a 30.0845 empty beaker. And then after the evaporation, I got that number. So let me do a little arithmetic here. 30, I want the big number on top, 0.1312 grams, subtracting out 30.0845 grams. What do we get? Make this 12, that's 7. Make that 10, that's 6. Make that 12, that's 4, 0. Yeah, it's pretty good. I'll double check my math later, but it looks like I got 46.7 milligrams recovered of benzyl, assuming it's 100% pure, which it probably isn't. And I started with, with the benzyl, 51.4 milligrams, and we recovered 46.7 milligrams. That's pretty good, right? Okay, the next thing I'll do is I'll get an IR of it. Let's see if it is actually benzyl. Let's go back to the IR. I ran a background earlier today. I don't think I need to do it again. You only have to do them once a month, really, but usually I have students do it more often just for practice. Let me get a spatula. Okay, so I'm going to get some of this benzyl, hopefully benzyl.
If there were more people in the room, would the CO2 level change?
Yeah, it does.
It
does change throughout the. It's cool. You get to see it when you're working in here. Okay, so I've got that benzyl solid on there. Since it's a solid, it won't really coat the zinc selenide crystal well on its own. But if I clamp it down with the anvil nice and tight, I should get a good reading. And remember, this has 2 benzene rings and 2 ketones. So let's see. This was the old spectrum. So I'll delete that one. Delete, and then I'll scan a new one. Instrument, scan sample, use these default values. Let's see what we get. It's looking good to me. Oh, it looks like I see some benzoin in there. Say okay to overwrite. Yeah, this looks good. Remember I said there could be trace benzoin. Already green. And if you click, you could toggle it off and then on again, off again, on again. And then what should I do, Demonpreet? Off again, on again, and this joke is not working on the lag. Never mind, I'll keep it on.
Okay.
All right.
Understand. Sorry.
It's okay. It's better live. Some things are lost. So I've got some peaks here, which make total sense to me. Oh, that does too. I don't know about this one. Oh yeah, these are good too. This all makes sense. Nice. So I think this strong one here, 1655, what kind of signal causes that? What shows up around 1700 in the IR?
The
Carbonyl.
carbonyl.
Carbonyls, yep. So I think what I've got here is benzyl with benzocaine impurity. Like I said, I only did 2 extractions of the benzocaine, 2 washes. And I'll put my name on there, initials at least. Yes, date, always date everything. It's good to date things because that helps you figure out when you're lost later. Okay, I'll put that here. Yeah, so the reason why I think it's got benzocaine is these 3 signals around 3400, 3300, 3200. These are for the amine of benzyl. I mean, not benzyl, benzocaine. The amine actually has, it's 2 hydrogens on the nitrogen because it's on a benzene ring and it makes 3 signals for the NH bonds. And then I've got, sp2 carbon hydrogens, and I do have some sp3 carbon hydrogens because the benzocaine has an ethyl ester. The ethyl has got sp3 carbons. And then I got 2 carbonyls, one for benzyl, one for benzocaine. We got to off our zinc selenide crystal. You don't want to leave that stuff on there. So I'll wet a chem wipe. Try to grab off the bulk of it. Pinch it off, get another wet chem wipe. Clean the anvil tip, looking good. And then I like to go with a dry one at the end. Nice, let's look at this IR spectrum again and make sure it makes sense to you guys. I think this is going to be mostly benzyl. Does the benzyl have any sp3 carbon hydrogens? Doesn't tell. And I think the carbonyl is here, and the sp2 carbon hydrogen is here, just over 3000. I don't know if this is it readable for you guys?
Yeah, we can see it a little bit, not the numbers really, though.
I'll take a picture of it and I'll add it to the final video too. So there's some benzocaine in here as well. So the NH shows up as these 3. And then the sp2 carbon hydrogen, same spot as the other one. Deciding which way to go. It's kind of ugly. There we go. And then there's a carbonyl. Hop over that one. I think it's the shorter one is my guess, because I think there's less of it. We'll confirm it on STBS. And then there's sp3 hydrogens. There we go. So it's kind of a jumble, but it makes sense to me. And see how the benzocaine evaporation is going. Still got a little ways to go. I think I'm going to go hit it with the Conair 1875. But but this will take a little while. What I'll do is I'll add this information and other stuff to the final video so you guys can check that out. And then the other extraction, the one with the unknowns, I'll do that at another time. This one took a lot longer than I thought. but it was good. I felt like you guys were following along. Did you like it?
Yeah, it was
Yeah.
interesting.
Yeah.
Made a couple mistakes as usual, but we were able to learn from, I overcame them. I actually think I got a little bit of a Sharpie marker inside of here. It's kind of a black tint to it. But the amount of impurity that causes that slight black imprint is so small. It's like probably 0.001% impurity. So it's not a big deal, even though you can see it. Okay, so I think I'll pause there. I'll finish up this guy's evaporation massing and get an IR of it. Oh, you know what? I'll show you one other thing really quick. Let's do this before I let you go. I'll show you what I was talking about, the IRs. So I'll share my screen again. Let's go back to SDBS. Let's look at benzyl first. Actually, benzyl does have that like. Oh, did I already have a? I already snapped out benzyl, didn't I? There's benzyl. Let's look at. I'll put that on a new panel too. Got benzyl already, and let's go get benzocaine. Oh, that's not. I think they might not like the way I spelled that. Did they? No. I think they have like a funny, maybe they go para-aminobenzoate on this one. I can never, what did I do? Okay, I'm bad at guessing this exact spelling that they want, but I can do the formula. So benzocaine is C6, 7, 8, 9, right? H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. NO2, I'm pretty sure. Ethyl, see, they don't have the dash, ethyl space P aminobenzoate. I always forget how kind of awkward spelling they're using there. But here it is. So you can see the 3 peaks that the nitrogen NH bond causes. So if I like kind of zoom in here, I'll show you. So here's the benzocaine. So the nitrogen, the NH2, has these 3 signals right here. We saw that on ours, but it was weaker because it was an impurity. And then you also have the just over 3,000 sp2 carbon hydrogens, just under 3,000 sp3. And you see the carbonyl. The carbonyl is closer to 1,700, huh? It's like 1,687. And then for benzyl, it's carbonyl. It's kind of got like 2 carbonyls. I think it's because when these ketones are facing the same direction or opposite, they're slightly different, is my guess. And then they're more around 1662, 1666, more to the right. And then it just has that one sp2 carbon hydrogen over 3,000. I'll go grab ours really quick and I'll transfer it over. I should use cam scanner a little better, but we can probably still see it enough, I think. Can you guys see it pretty good?
Yeah, it's there.
Yep.
Yeah, looks like it.
Can you see how like the 3 NH2 peaks are here, carbonyls, I think. Yeah. So that demonstrates, that we can separate them with extractions. I didn't do enough of the washes with 1 molar HCl and then 6 molar NaOH precipitations, because benzocaine's always a pain like that. You usually have to do a bunch of them, and I felt like I was going overtime, which I'm even going more overtime now.
Here's what's left of the evaporated benzoin layer, and it's a black solid now because it got a little bit of a Sharpie ink in it, but I don't think it's that much. The color could be very black, and it's still way less than 1% impurity. So I think might be the case here. I wanted to move it around a little bit, just kind of allow it to evaporate the solvents a little more. But yeah, maybe I just lost some on this batch of that. Oh well. So let's see how much this weighs. We weighed this beaker empty earlier. Let's see how much it weighs now. It's looking like 1.101.930. I scraped out some of that benzoin, which we assume is benzoin, and Sharpie onto the zinc selenide crystal of the IR. Let's lower the anvil down. Like I didn't get a lot of solid on that time. I'll move some over. Okay, let's see. If I crush this down onto the zinc selenide crystal. Nice and tight. Let's see what this IR spectrum looks like. See if it's going to be our benzoin. No, not benzocaine. Scan sample. Use the default values, and we will see. Benzoin looks really good. So that black impurity from the Sharpie, it was a small, just a trace amount of impurity. Yeah. We'll compare this to like STBS and see how close it matches. I bet it matches very closely. In my text box, I can just modify it. That was the benzoin one from before. This will be benzocaine with the Sharpie impurity, black Sharpie impurity, and I'll label it up and I'll share it with you.